Good day to you. This is Anagalactic with another science presentation in cosmic geometry. We are currently into the third presentation on this day, the 10th day of May, 2024 from Chico, California. In a recent episode, in what I call the Unimetrics series, I went through a rigorous 3-hour presentation of the mathematical and geometric basis for a new look at space, really. We've been talking about space for a few millennia now. Space seems to be everywhere. It does seem to be the basis of science in one formulation. Now, what do we mean by that one formulation? Well, science is many things, so one must always drill down correctly in order to have the correct foundation for the prospects ahead. What are we doing? It's important to reiterate, but we'll go through it swiftly. We're attempting to understand the universe. This would ordinarily be from an astronomical perspective, which is my primary perspective, and to which we must return. But in order to understand the universe as fully as we would like as 21st century scientists, we are now aware of several things that really were discovered in the 20th century, an amazing century for science, in the sense, of course, of the two ultimate mysteries. And they're logical. So what we're after is the structure of the universe. This depends on measurements, and therefore comes from data from such things as the space telescopes, which we've been launching into outer space, because it's much easier to take astral photographs in outer space where there's no interference of the atmosphere. So currently our James Webb Telescope is probing well beyond another far barrier, and we want to return to that as quickly as possible. I am an astronomer. I got interested in astrophysics, as is fairly inevitable if one is lured that way. It certainly is a wild lure indeed. And from there one can actually get into cosmology, the standard models that now dominate physics, which is more than just the cosmological model. When we study light, that's really the nature of the universe. From our perspective on Earth, our information comes to us from light. The only other real source of information other than light is gravity. Gravity is much different from light, or much different than light, depending on which preposition you like to use. The British have a different convention, but it's become exchanged, I think. So different than and different from is pretty much considered to be equivalent by all people, I think. You wouldn't have any raised eyebrows from saying it one way or the other. Now, we're going to just quickly ground ourselves on a much broader base than I've been doing so far. I concentrate on geometry, which is a preferred approach to a certain frame of mind. It's not the only approach to science at all. We need to understand the universe, and in order to do so, we need to understand light and gravity. Both of those get us into mathematics, of course, and Einsteinian spacetime and the quantum paradox. Why? Because light is quantum. Quantum, whatever you construe that word to mean, light is definitely it. Whatever you construe as the quantum paradox, or what is quantum mechanics, you're talking about light. Not only light, though, because many of the characteristics of the paradoxical situation found in subatomic physics has to do with electrons. And electrons are the major source of light in the universe. That's certainly fair to say, because it's the electronic shell system of an atom in a star, in the atmosphere of a star. The core, the corona, as the light comes out, it's emitted from atoms, and it's really from the electrons. The protons do not participate in that, although protons can emit light, and we'll cover that. We do need to know the structure of light in order to interpret what it tells us of the heavens, or heaven, or the universe, however you want to put it. The cosmos is a preferred term to me, because it's neutral. Say universe, it sounds like you've been maybe brainwashed, at least to me. But if you say heaven, it sounds like you may be religious, and now there's a red flag. But if you say cosmos, that shows you thought about it, and it is neutral. Even someone who's not too familiar with what you might mean by cosmos would readily understand. Might even be prompted to ask, you mean the universe? And then you say, well, yes, that's exactly what I mean. But you said cosmos. And that's where we get cosmological from, and in fact cosmic, if I've got that etymology correct. We want to understand the whole thing. We want to know all about it, everything, everything. And what does that really imply? Let's just give some categoricals. We'd like to know how galaxies form. We really want to understand the interacting galaxies, the dancing galaxies. I do. I'm not alone. Edwin Powell Hubble wanted to. His tuning fork for the... That's really as far as we've gotten in the evolution of galaxies, is Edwin Powell Hubble said, well, there are spirals, and then there are sphericals, which typically now are called ellipticals. They might have been called sphericals, but that was thought a bit too extreme, I guess, because actually they're ellipsoidal, so elliptical is good enough. But it does mean essentially spherical, of course. So we do have two kinds of galaxies, and we sure would like to know why. Why do we want to know why? Because as you get understanding, you learn that this is exactly what you're blueprinted to get. The only problem, if you could even call it a problem at all, is you become addicted to it, and you want to know more and more. This has a moral injunction involved here. You don't want to be greedy. Well, I've made apologies for science on its behalf, because really science is under... there's an expectation that scientists have answers. I agree with that, but the problem with that is that scientists don't always have the answers, but they're pressured into giving the answers. And so you have sometimes changes, sometimes major changes, in how science adjusts to what it sees, because sometimes we see something that forces us to change our mind. Now, we're accustomed to thinking these days, and really statistically rightly so, that it's a lot less likely for a sea change in science now compared with, centuries or millennia ago. You could expect sea changes at the beginning because, first of all, the universe is so huge, and second of all, because we don't have an organized system of getting at it. That took time to develop, of course. Now, today we're going to expand on the geometry series. Over the past 500 and more lectures that I've produced over the past 3 years, I have covered some dynamics and mechanics. But really, now's the time we're actually going to get into mechanics and dynamics. Now, this is a very interesting study all in itself, although it can be brief or long, because science will draw you in every direction. And it's sometimes difficult to know if you have to budget the way you accord your work time. It's easy to get pulled away into study of mechanics and dynamics because both of these subjects are quite deep. We don't really want that here. This isn't a comprehensive course in either dynamics or mechanics. We simply want to know, really at this point, just what in the world that means. And so that's how we're going to begin today. We'll be looking at something in Wikipedia here, which that was the last article, dynamics. You see what Wikipedia says. Now here, it turns out there's a whole bunch of dynamics, and the one we want is actually not easily found in this list. But what is really wanted is classical dynamics. So I'm going to type that in. And what is also classical, well, actually that's the one we want, is classical mechanics. We're getting to dynamics, which is the one we really want. Now, classical mechanics, as you can see, I'm highlighting it down here. Oops, don't want to highlight all of that here. It is a physical theory describing motion. So it describes motion of everything from projectiles, parts of machinery, to planets, stars, and galaxies. Well, that's what we wanted. So it is a theory of motion. And then there's a lot more that we could read. But now let's get an overview of what is dynamics. And see what we can disambiguate here. Now here, what we actually want, I'm sorry, I began to say this right, but it's, if we go to analytical dynamics, then it says analytical mechanics or theoretical mechanics. So this is where dynamics leads us to. It's redirected from analytical dynamics. This is where you find out about dynamics, is in the article on mechanics. So what I'm going to do is a page search using Command F, which I think is a cross-browser convention, and you'll see up in the corner. Let me do that again. I'll hit Escape. You saw it go away. Look at the upper bar just below the menu bar, and you'll see when I type Command F on a Macintosh, it produces a search bar. I'm going to type in the word dynamics and see if we can find out what the Wikipedia says about this. Okay, here we go. Something about Legendre, Hamilton, and Jacobi. Those are famous names. Here's talking about Lagrangian mechanics and Hamiltonian mechanics and Newtonian mechanics. These are the three most famous of the mechanical theories. There's a Hamilton-Jacobi theory. They're going to talk about a lot of stuff. We want to skip that, but you see, okay, you see also dynamics. Well, let's click on that, and it brings us back to the top. So you're not going to get too much more on dynamics, but really the key word is motion. Motion. Now, the way I would put it for dynamics, and we could just do a general search here on dynamics and see what, for instance, Britannica. This is quite a reliable source. I don't really see there's much. Okay, dynamics, branch of science, subdivision of mechanics that is concerned with the motion, okay, in relation to the physical factors that affect them. Now these words, I'm glad all these words are put together. I want you to see these together. Mass, we're not going to talk about yet, but we're going to get to it quickly. It's the other three words: force, momentum, and energy. We're going to talk about that today because we need to know about it now, because we discovered that in the two-component system of numbers that describes a geometrical object and a whole geometric space that's much better than our linear grid. I'll just say it's a lot different than our linear grid, and it offers several advantages over the linear 3D grid and the linear 4D grid of Einsteinian gravity space, also known as space-time. That is a four-line system. We have a superior system now. I believe that can be proved. I have no doubt about it, but formal proof in science is very important, especially for such a rather, I mean, that's hard to take seriously, I would have to say, but that's what we're going to study today. Now, all of this is preparatory for our reintroduction of Rudra Joseph Boscovich, who composed an amazing dynamical system right after Newton and Leibniz. Boscovich appeared in Europe in the 18th century and came up with a two-force system that has grabbed the attention of modern physicists, and not just in quantum mechanics, but also in regular mechanics, and which we see has to do with motion. But really you should think of, or I tend to think of, mechanics and dynamics are really better thought of together as two separate things that are so closely related that it's rather like thinking of electricity and magnetism, that they're always associated. And the best way to formalize that, which is really to extend the definition, but constructively, and a scientist should do this in his own mind, when he feels, compelled to do it, which I do now. This is cogent. I think you'll like this. The dynamics has to do with the structure of the interacting components in terms of force. That would be dynamics. And we're going to drill down to the meaning of that word force, which is going to become critical because it's actually the correct basis of physical dynamics is the concept of force. Not quite the same as energy and not quite the same as motion, but all these things become related. And when you throw in the word momentum, and then you realize you're probably talking about angular momentum, now you're talking about the source of force. Because there are only two forces, and it's time to drill down, so I'm going to do so. But before doing that, I want to show you something else that we're going to be using today. This is from Geogebra, and I'm going to switch to that screen in a moment so we can actually construct this together, because I think it's time for us to do that. We're actually going to construct the universe in visualizable form. I don't think that's done in very many classrooms, except with one of those accursed funnels that shows the beginning of the plasma Big Bang funnel, and then it just expands outward. Well, that's really rather ridiculous. It's easy to poke fun at that, but it's kind of like the dinosaurs. All of a sudden, the dinosaurs were just all over the inside of the children's classrooms. Well, the same thing is true of that funnel that shows the expansion of the universe from the Big Bang. I really consider that to be pure propaganda. All jokes aside, even if that model is true, you can't do that. Even if that model were true, you shouldn't do that. But that's rather difficult to say, because if it were true, then it would probably, because the periodic table is true, nobody doubts that. That model of the Big Bang explosion and the inflationary period and everything that they propagandize people with, none of that is remotely proved. None of that really, actually, to be perfectly honest, none of that has really more than a shred of evidence behind it. Far, far short of the required prima facie case for their really ridiculous theory. And it really is. Now, it's interesting, anything that comes to prominence that pronouncedly in science obviously has something going for it. We'll get into that, but I'll just say it's really misleading. And I could go on, but part of what we're doing is trying to get science out of the sand trap that it's in. We'll use the golfer theme rather than someone sinking in quicksand. He's trying to hack out of a really notorious sand trap. By the way, I saw Tiger Woods locked in a sand trap where he actually had to hit it almost straight up on a chip to get over the lip that was hanging over. And my goodness, he missed. And other guys missed the same shot. It was horrendous. Anyway, we are going to be studying the Boscovich force curve in a very elementary form. I think you're going to like this very much. So the nature of the universe is such. I wanted to throw this in. I've been making a big deal out of I want you to see I've been making a big deal about going live, like having a live stream. I believe that's the right term for it. And I did some preliminary research, and then I just didn't like what I saw. And it's a very difficult decision for me to make because it's a huge commitment, in my opinion. Now, it's probably just another chimera. Nothing is really is as difficult as you make it out to be at the beginning. It's just a matter of being methodical and persistent. You'll make it. It may be that you're scared for a reason to jump in. And that shouldn't induce a person to give up. But it should possibly and possibly likely be an indication that you need to slow down and have a strategy. That it could be a warning, whether you believe in that sort of thing or not is intuition. There's something that just feels wrong, but that doesn't mean that you should stop your effort. It means that you've encountered something that is necessarily overwhelming temporarily, but it is remarkable what time can accomplish on behalf of us. Excuse me, I do have allergies, and I just rubbed my nose, so I may look like Frosty the Snowman for a while, after someone threw cherry cola on its nose, which is not a nice thing to do to a snowman. But look at it, it went away already. Well, anyway, we're not going to do experiments on my nose. That's a touchy subject right there, the nose right now. Allergies, ooh. All right, so so we are going to build the universe right now, and from this building, we're going to show what space really is. And from that, we're going to show what time really is. You're actually going to see it. Space is not what we think it is. It's just as mysterious as time. It would have to be to have the quality that it does, which is the medium of light. Now, it's not ether in the old sense, but it's hard to say if space is something or not. But after Einstein, it's now much more reasonable to assign at least one quality to space. Well, according to my research, which I'm going to share with you now, it's not that space either has some qualities or none. It's that it has exactly one quality, but we've never identified what that one quality is. And now I'm capable of stating, which I believe is the first time this has ever been stated. It will have to be proved, but I am going to state it because I have proved it, and I'm going to show you the proof, is that the correct definition of space gives you the correct definition of time. And neither one of them is either what is currently being surmised in science, physics, nor is it obvious what either one of them actually are. But when you hear or actually see what they actually are, it just makes sense. It's very strange, and let's start. I want you to see this because it's easy to talk. I'm now going to switch over to the Geogebra screen. And I'm simply going to start something new here so you can see how this is done. I'm going to say new, don't save. Now, I don't want the grid, so over here in the corner, upper right, you see a little tiny, well, there's the hamburger, the big one, this one. That's the big menu. The one below it is this one. I'm going to click on this grid, and it gives me a choice. I want to take out the grid. I'm going to center this now, and I'm going to close this up a little bit over here on the left. And now we're going to use the tools up here. You'll see if you look, I'm kind of breezing over them. We want the one with a circle, and we want the circle with a center through a point, or circle, center, and radius. We'll use two, each of these. But for this one, circle with center through point, that means you're going to stretch it yourself, and it shows you down in the lower left. I think you saw that highlight. Select center point, then point on circle. That's a little misleading. Watch what happens when I click on this, and now it tells me select center point. We want the origin. And now simply move the mouse. And we want radius 1. This thing is programmed to click on 1, I think. Yeah. Let's make sure. I'm going to open this up. Yes, 1, 0. That's what we want. Now that tool is still highlighted. So I could select the center point again and stretch it again. This one we want radius 2 and click. So now we have those two. We can turn off those points, which may be a nuisance. See, I turned it off. Oops. You see what happened? I forgot. The tool is still highlighted, so it thought I wanted to make a circle. There is no undo, and if you do Command Z, it doesn't work, so you have to delete it. But it's not done yet, so it's holding the grab. So I'll just click Escape. And now that I've clicked Escape, it's gone to this one, the very first one, which is your safe zone. It had been still highlighted on this, and since I selected this, it just thought I wanted to make more circles. So I'm going to do it again, and then this one we want to be radius 4. But now that I'm done, I don't want to start doing anything else. I want to go over here and click on this. And now I'm safe. Now I can turn off D and B, and I could turn off the other ones if I want. We really don't want A. The little letters here that show this circle, and this circle, we're going to keep. because they're not really in the way. But now we have three concentric circles making 4 regions. This is significant in order to divide up the spherical zones. These circles represent spheres. This is an introduction to the structure of the universe that we just covered in Unimetric 7, I believe it was. That was only 3 days ago, and if you would like to review that, you may, but you probably don't need to. This is fairly self-evident. This inner circle is the inner surface of universal space. This circle is the outer surface of universal space. So in between this circle and this circle is the universe. This area out here is imaginary space all the way out to here. And this is the hyperspheric surface of the hypersphere. There are 3 surfaces here. This one, the hyperspheric surface, which we will not be dealing with directly at first because it's the hypersphere. And in fact, we don't want this. So this is the universe. Now I'm simply clicking and dragging and expanding so you can see our universe. Now here, this is obviously not to scale, but the reason we have these 2 concentric circles is because of the numbers that go into the universe and to the center. And this is the inner surface, the actual center of this space, which is not 0, but as we discussed extensively, does have 0 inside of it, which is where the 2 lines meet. So linear space is embedded in spherical space, as we've proved. That really was the major part of my discovery originally, is that simple fact. So we do have an interior, which you see has radius 1. I'm going to turn that one off as well. I'm sorry, not that, but this circle. In order to make it smaller, and here, I'm going to do the same thing, circle with center through point, and just go out that far. Now get up here to get out of trouble there, and then turn off the dot. That's more to scale. I think that's a little easier to visualize because this center inside the small circle, that is imaginary space. So which is interesting, isn't it? Because it has a radius in this geometry. That is the infinitesimal of spherical space. It is defined as the reciprocal of this circle. This circle has a number, and it's infinity over 1. And it's spherical infinity, so out in the outer region, outside of the outer circle, that is the infinite extent of spherical space, which itself does not have a number except a symbolic number called lazy-8, which we interpret as spherical infinity. And the fact that the number at the edge is infinity over 1 shows that it's the highest number of all. And it's so high that it's imaginary. So it is unique. It does represent both the edge and what's beyond it. That is not true of the inner surface. The inner surface is actually a number, a generated number, and we're getting to the surface of the inner sphere has a number. It's the number 1. But the way we got that number 1, this number is infinity over 1, and it actually is the edge and everything beyond. But at the inner surface, the surface is not part of the interior. In other words, the inner surface is part of the universe. The outer surface is not. And here we're talking about the finite universe that we must have in order to compute the universe to any degree. It has to be finite. The question of whether the universe is infinite or not is a pure question of philosophy. We actually don't need to answer that question as long as we know what infinity is as it is part of the system. And infinity is the surface, which technically I should say outer. It's the outer surface and beyond. Okay? But the inner surface here has a value. The outer surface does not have a value, because infinity is actually outside of it and one is inside of it. And that one is represented also at the surface. So you could say that the surface of the universe from the inside out is one. And that turns out to be true. The universe actually is a universe. It's one all the way through. All the spheres that are between the edge and the center surface all have the value of 1 in spherical number space. So they are two-component numbers that multiply to 1. This inner circle is one of those numbers. And it represents infinity over 1, this number, times the point center. And the point center you cannot see, although you can, it's inside the inner surface. That's actually 1 over infinity. And that has a radius in imaginary space. So you're looking at the complexification of real space. This contains imaginary space, and in fact we can now say it the correct way. The universe is contained in imaginary space. It's not that imaginary space is necessarily in the universe, but we're going to find out that imaginarity is in the universe, which is interesting because of the way we interpret imaginarity, which is infinity. There is infinity in the universe. It's in all the numbers. All the numbers have 2 infinities. The entire universe is the balance of 2 infinities. And what's outside the visible edge has a number. It's infinity over 1. And the center, which is only inside the inner surface, that has a value of 1 over infinity, those multiply to 1, and that is this surface. So this inner circle has the value of 1 with nothing inside of it and the spatial universe outside of it. We discovered in our last lecture that the surface, it's a sphere, correct? That is a second dimension, and it's the second dimension of spherical space. The primary dimension of spherical space is the pressure system, because it's linear. It's spherically linear, and there are only 2 spherical linear forces. This is not a contradiction in the slightest. It's actually an integration that solves all of our problems in physics. That these 2 circles represent 2 force relationships that explain all things. From light to gravity, it is the unification theory itself. It's the unification solution. Both for electromagnetics, quantum dynamics, the laws of the universe, including gravity, and the propagation of light in free space, giving us an absolute definition of the structure of the universe that is explanatory to an integral degree. From now on, we're going to get solutions that are infinitely better than the ones we've been getting by using this way of looking at things. Okay, I think that's enough for that. I wanted you to see this, that I haven't given up on getting live. I want us to go live. You can see why. You've got to be in the audience to ask questions. This man is an expert. Dejan Shkadrov. His name sounds like Shkot. It's Shkadrov. So I like this guy because his name sounds like mine. Well, whatever. So he has a lot of information on how a Mac OS user who has Wi-Fi and wants live stream might want to decide on what to do, because there are other choices besides YouTube live stream. There's also another way to do live streaming, and actually from some research I've done, there are 3 major methods of doing live streaming. Each one of them requires study, and I haven't done that studying yet. But I am determined to I'm committed to this. So I did have a little glitch there. I didn't like what I saw, and I don't like having to do this much work, okay? But I'm just being a crybaby, so I'm going to do the bloody work, you know what I mean? So I wanted you to see that. Now here we've been through our tour of mechanics and dynamics. I wanted you to see that in order that you would understand this. The Boscovich force curve. Here's one of my lectures from a year ago on Boscovich force curve, using the work of Roger J. Anderton, a major name in this major topic, and Dragoslav Stojkovic, which, as you can guess, is probably from Croatia, just as Ruger was. But I also wanted you to see this because of several aspects, and I want you to see several of these investigations, just briefly, not right now, but look at this, for instance. Oh, I did want you to see this. This is, I don't know why this just says A. I forgot I think it's Anthony Prince. Anyway, he is an absolute genius. It's not Anthony. I'll think of it in a moment. But all right, that's enough for that, and that's enough for this introduction. We're going to have a lot more to do with those 2 circles you just saw in the upcoming lectures. So I hope you enjoyed this brief introduction to where we're going. We're actually going to get to hyperspace fairly soon, and you could see it. It's the outer part of the universe is hyperspace. And by the way, that point at the center is also hyperspace. They're related. Everything in that simple diagram is related. But once you see Boscovich's force curve, that shows where the two that shows where the 2 infinities meet at the center of the quantum. So this is absolutely revolutionary, just mind-bogglingly enlightening stuff. And I myself am just beginning, but I can hardly wait to show you how explanatory this is. Just all the mystery of time and space that you just hear about, people coming up with the craziest theories. Well, it turns out there's reasons why they're doing that. And I'll show you what it is they're trying to see. The truth is always stranger than what you try to make up to explain it. Because if you're incapable of explaining it, it's not because the universe is trying to fool you. It's because the universe is trying to make a man out of you. The real definition of a man. And this goes so deep that I don't dare say any more, and I am dead serious on that. You're in for a treat. Stay tuned to Anagalactic. The best is yet to come, just like the Frank Sinatra song. Keep looking up at night. It's a good time to look at the night sky. We'll be right back with the most mind-blowing... This does not end either, which is good news for someone like myself and my sister, who we do not like a good story to end. Well, this one doesn't, so stay tuned. We'll be